answer when you are finding the domain of a composition. Here's why. Let's say I gave you some functions. F of x is 1 over x. And g of x is 1 over x minus 1. If I asked you for g of f of x, what do? You start with f. So f is 1 over x. We plug that into g, so 1 over x minus 1. Now, it's not proper notation to leave a fraction in a fraction. So the easy way to get rid of this is to say I'm just going to multiply top and bottom by x. That would give me x over 1 minus x. Okay, there's the composition. If I look at that, what's the domain of this? What can x not be? 1. So it can't be a positive 1 because we have a fraction and that makes the bottom of the fraction 0. Alright, but that is not the total domain. Because what if I said find g of f of 0? If you plug a 0 into f, what do you get? Undefined. So we know x also can't be 0, but there's no way to tell that just by looking at that final answer. Now, we also can't just look at the two original functions. It's just purely coincidence that we got 1 here and this was 1. So what we need to do is we need to look at the inside function. Because the very first thing you're going to do is plug the number in there. And I know right at that point, x can't be 0. And then you have to look at the final answer to figure out the second piece. So for a domain of a composition, there are two places we have to look. We have to find the domain of the inside function and the final answer. Combine these. So the final domain, we put those two together. So, two places. If you only look at the final answer, you'll be right about half the time. Okay, so make sure you're checking both. You also can't just look at those original functions. So now we're just going to practice some of these. Right. So I want g composed with f. So g of f of x. So f is x squared plus 3x minus 1. I'm putting that into g. So g is 2 times the thing we're putting in plus 3. We distribute. 2x squared plus 6x plus 1. Alright, so if I want the domain, we have to look. The final answer. No fractions, no radicals. So what's the domain here? Mhm. And then we look at the inside function. So this inside function, no fractions, no radicals. So what's your domain? So since both of those were polynomials to begin with, when we compose them, the domain is still everything. Is that one okay? Is that one that's a little more interesting? Does the order of the composition matter? Does it matter if I say F composed with G or G composed with F? Yes, you get different answers. They will also have different domains. So we do have to be very cautious there. So F composed with G. So we start with G. And I am plugging that into F. So F is 1 over the thing we put in plus 2. All right. What would we do here? Multiply. We can't leave a fraction in a fraction. So, we could get a common denominator and flip and multiply, but the shortcut is just look, this x minus 1 is on the bottom. So we're just going to take the top and bottom of this fraction times x minus 1. So 1 times x minus 1 is x minus 1. 4 divided by x minus 1 times x minus 1 is 4. Plus 2 times x minus 1. So we get x minus 1 over 2x plus 2. That's our final composition. For the domain, where do we need to look?
Inside and through.
The first function we plugged in and the final answer. So we know in a fraction the bottom can't be 0, so x can't be 1. And so when the bottom can't be 0, so x can't be negative 1. So my final domain, my rule, if it's more than one value, I do let you just list it, so x can't be positive or negative 1. If you did the interval, it would be negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. So realize, we couldn't just look at that final answer to get it. Is that the same as the domain if I look at the two original functions? No. So the only way to get it is to do that composition and then look at those two parts and put them together. Right. I want you guys to try one. Okay. So G composed with F. So if we do that, G of 3 over x minus 1. So you get 2 over 3 over x minus 1. So then, what do we do? So we get 2x minus 2 over 3. What's the domain of the final piece? It can be anything there. What about the inside? So our final domain would be negative infinity to 1, union 1 to infinity. Are those okay? And you understand how to clean up those fractions and fractions? You guys try this one. We have f of x squared plus 4. So that gives us x squared plus 4 squared. And then how do we square that? FOIL. So if you write that twice, you get x to the 4th plus 8x squared plus 16. What's the domain of the final piece? And the inside? Same thing. So if they're both polynomials, even when we compose them, we still get negative infinity to infinity. All right. Let's do one with a radical. So I want g of f of x. So f is the square root of x plus 2. And if I'm putting that in, we have 2 over the square root of x plus 2. Is that okay for how to leave your final answer? No, we never leave radicals in the bottom. How do we get it off? Well, we can't just square, but we can multiply by the same thing on top and bottom. So it essentially making it square if we just multiply by the same thing. So we get a 2 square root of x plus 2. Then on the bottom, it's the square root of x plus 2 squared, so the square roots cancel and we just get x plus 2. Can we cancel those 2's? No, because more than one term on the bottom. All right. So here is my composition. Domains. Let's look at the original inside piece. If we have a radical, what do we know? So x is greater than or equal to negative 2. Final answer, this one we actually have the radical again, but we already found that piece. We also have a fraction, so we know that x can't be negative 2. If you put those together, greater than or equal to negative 2, but cannot be negative 2. It just takes away the equal to, so it just makes it a parenthesis. Negative 2 to infinity. All right. Any questions on this? Okay, so we have that Math Excel assignment is due tomorrow. So at 3 o'clock, but you should be able to get it done. How are you guys progressing on that one? Making headway on it? So that's your top priority. There are a few domain questions in there. I will also go ahead and open up the handout for tomorrow on Google Classroom just because I've had a few requests from people that are going to be gone and want to get that done. So we're looking at a quiz on Monday and it will cover sections 4, 5, and 6. So section 4, that was back when we were looking at the absolute values. Section 5 was the piecewise, and then section 6 is all the stuff that we have been working on. Okay, so first work on that Math Excel assignment and let me know